question here, this is also piecewise defined function. So your fx is equal to minus 3 if x is less or equal to minus 2. So only when the domain is less or equal to minus 2. How about the next one? Fx is equal to x squared. This is a square function. So the domain will be from x starting from minus 2 not included until 0 included. Next, let's see the next function. The third one is 1 over x. This is a reciprocal function when your x is more than 0. So let's rename this equation number 1, 2, and also 3. Now let's look at one by one. See the first equation, which is, this is a constant function. So the shape of the graph is fx equal to minus 3. What do we want? We want less or equal to minus 2. So let's find the endpoint first. Now you're looking at x less or equal to minus 2. So let's check. Minus 2, the y coordinate will be minus 3. Okay, make sure you have that point there. So we have this coordinate here, minus 2, minus 3. So we want to take less or equal. So let me write here, we are talking equal sign. And then we'll take to your left. So this part here. So now let's transfer the endpoint here, which is minus 2, minus 3. So this is included, minus 2, minus 3. So transfer the point, then transfer the shape of the graph. So it will go towards your left hand side. Now let's see the next one. This is just a smiley graph. So let me graph it. Alright, so the shape of the graph is a smiley graph. And then it's written here that it will exist from minus 2 until 0. So when x is minus 2, your y will be equal to 4. And another one, when your endpoint is 0, therefore the graph will be 0 as well. This is included. And another one, this is also included. Minus 2, 4. So let me highlight your answer is this part here. Now let us transfer this to your final answer. So for the first one, you have the point 0, 0. And then it will go up until minus 2, 4. So this is minus 2. 4 is somewhere up here. Minus 2, 4. Okay, so now we just connect the dots. So let's just connect the dots here. Then you have finished equation number 2 here. Now let's go to equation number 3. Fx is 1 over x, which is a reciprocal graph. And we just want to take x more than 0. So what you need is, first of all, let's draw our graph. In order to graph the reciprocal graph, you need to be aware that we have asymptote here at x equal to 0 and asymptote here at y equal to 0. So you cannot touch these 2 points here. So let's just graph it now. We want a reciprocal graph. So this is your graph. Now let's fill in a few important points. 1, 1. Another one here is minus 1, minus 1. So now let's look back. We want to take only for domain x more than 0. So you just want to take whatever graph you have at x more than 0. So we must take this answer here. So now let's transfer the shape here. Graph. Now you have the same graph as this one here. Let's put in our coordinate here is 1, 1. So this is the final graph of your piecewise defined function. Now let's go to the next question. This is also piecewise defined function. So the first equation here is fx equal to 3 if x is less or equal to minus 3. The next one, fx equal to minus x minus 1. So please take note that this is x power of 1, meaning that this is a linear. So you want to solve for x between minus 3 and 0, not included. And finally, we want to graph fx equal to square root of x if x is more or equal to 0. So let's name this as equation 1, equation 2, and equation 3. So now let's focus on equation 1 first. Your fx now is equal to 3. So this is as if a constant function. So now let's graph fx equal to 3. Therefore, 3 is somewhere up here. And you should label this is 3. So what do we want? We want to take x less or equal to minus 3. So be careful when x is equal to minus 3. It is somewhere here, minus 3. So the point here, which is included, the coordinate is minus 3, 3. So you want to take less or equal to minus 3. So this means that we want to take the left part here. So now let's transfer this point here and also the shape of straight line. So first of all, let's transfer the point. It is minus 3, 3. Included. Okay, you have transferred the point. So now you want to transfer the line. So just transfer to the line to your left hand side. So since this is the smallest domain, therefore you can write the arrow here. So we are finished with graph number 1. Let's go to graph number 2. Fx is minus x minus 1. So now you want to solve for fx equal to minus x minus 1. Now you can see that equation number 2 is a linear. The highest power is 1. So how to graph a linear function? 2 points is enough to draw a straight line. Okay, so let's see the end point here. So when your x is 0, now it will become minus 1. Next, we'll need minus 3 as the end point. So when your x is equal to minus 3, what is your y is equal to 2. So now let's look where is 0 minus 1. Somewhere down here. How about another one? Minus 3, 2. So minus 3 is here. And then 2 is somewhere here. So let's do a round bracket here. Okay, now let's continue to connect the dots. And then let's highlight where we'll need. It's from minus 3 until 0. So from minus 3 until 0, this is the shape of your graph. So as usual, when you want to transfer this answer towards your piecewise defining function, first of all, let's transfer the point first. So for the point, it's very simple. First of all, is 0 minus 1. And this is not included. Another one is minus 3, 2. So we already have minus 3, 3. So let's just draw minus 3, 2 is somewhere here. And then let's just connect the dot. So now you have finished transferring the point and also connect the line. Now let's see the third one. Fx is square root of x. So we know already what is the shape of this graph, which is this graph will be going to the right. So now let's see the domain. Your x must be 0 and included. Okay, so since this is included, so this is included. This is the point 0, 0 because when your x is equal to 0, the end point, the y coordinate will be square root of 0, which is also 0. So let's start the graph from 0, 0, and then let's go beyond that. So your answer is this part here. So as usual, let's transfer the point. So now let's transfer this point here, 0, 0. And also after that, let's transfer the shape. So it will go towards your right. Since this is the last function, let's make an arrow here. So it's indicate that we will go to positive infinity. Now let's try to see the domain and also range for this function here. So as usual, domain for x, just starting from here, this is all included. Up until here, 1 is included, 1 is not. So you can still go on. Up to here, this is not included, but this is included. And you can go on until infinity. So for the domain, it is from minus infinity until infinity. You can also check at the question here. Okay, so x covering from minus 3 okay, and then it will go up to minus 3 and 0. This should be combined. You can also check the domain from the domain given. So as the first function, this already covered x less or equal to minus 3. The next one, they only cover a small part, minus 3 until 0, but both of them are not included. And for the last one, x more or equal to. So we can see that this domain here take all real number. So let's find the range. Starting from down here, you don't have anything. And then let's start with minus 1. So minus 1 not included. Let's go up. Okay, so continue going up. This is a hole, this is a line, so you can still go on. So this one have been covering for this. Okay, and then up until this point here. We won't stop here because this function here goes until positive infinity. So our range y is from minus 1 not included up until infinity. So this is the final answer of your piecewise defined function.